Welcome to a deep dive.
Into documento.txt.
Okay.
Get ready to explore 9 theories about the universe that are so mind-boggling they make black holes look like child's play.
Yeah. Documento.txt presents a fascinating mix of classic concepts and cutting-edge ideas
We're talking multiverses,
that are sure to spark some serious reflection.
simulated realities, and even the possibility of planets that are just right for life, like finding the cosmic jackpot.
It's true, these theories really challenge everything we thought we knew about the universe.
It's like, imagine going from thinking that the Earth was flat to suddenly pondering infinite universes talk about an upgrade.
Hmm.
But for centuries, humans have been trying to make sense of our place in the cosmos.
Yeah?
And these 9 theories from documento.txt, they're like looking into the universe's most intriguing mysteries.
And what's so fascinating is that these aren't just wild guesses. Documento.txt delves into the scientific reasoning, the observations, and even the debates surrounding each theory.
Okay, let's unpack this cosmic suitcase, starting with a concept that's been blowing minds since the ancient Greeks, the multiverse. It's the idea that out there, beyond the reaches of what we can see, there might be countless other universes, each with its own unique set of physical laws and possibilities.
Right, and Documento.txt points out that even ancient Greek philosophers like Anaximander were pondering the idea of infinite worlds. But it was the atomists, like Democritus and Leucippus, who really embraced the concept of numerous coexisting universes.
So, like, our universe is just one bubble in a cosmic champagne flute that's overflowing with possibilities.
They believed that everything was made of these tiny, indivisible particles colliding in an infinite void, creating an endless number of possible worlds in the process.
Okay.
But this isn't just ancient philosophy.
Mm-hmm.
Modern physics has actually presented some intriguing evidence that might support the multiverse theory.
Exactly. Cosmologists are looking at things like the cosmic microwave background radiation, the afterglow of the Big Bang, and they're finding some strange patterns.
Oh, wow.
These patterns, they say, could actually be bruises or imprints left over from collisions with other universes.
So like cosmic fender benders. That's wild.
Yeah.
But here's the question.
If there are infinite versions of ourselves out there, making different choices, living different lives,
Right.
does that change how we live this life?
That's a question for the ages.
Yeah. I mean, it's a lot of pressure knowing there might be a version of me out there who actually enjoys doing taxes.
It really makes you grapple with concepts of free will and destiny, doesn't it?
Speaking of grappling with big questions, let's shift gears from the potentially infinite to the potentially habitable.
Okay.
Documento.txt also dives into the tantalizing theory of Residuos de Oro planets or Goldilocks planets. Planets that are just right for life, not too hot, not too cold.
Sort of like finding the perfect parking spot on a busy day, but on a cosmic scale.
And the exciting thing is that this isn't just a hopeful fantasy. Documento.txt highlights the incredible work of the Kepler Space Telescope, which spent years searching for planets orbiting other stars, and guess what? It found them. Thousands of them, in fact, with some estimates suggesting that there could be billions of potentially habitable planets in our galaxy alone.
Billions.
That's more planets than there are reality TV shows, and that's saying something.
So we've got these potentially habitable planets out there, but what are the chances they're actually like Earth?
Well, that's where the Residuos de Oro concept comes in. It's all about finding planets within the habitable zone of their star, that sweet spot where temperatures are just right for liquid water, a key ingredient for life as we know it.
So we're talking Earth 2.0, maybe even with better coffee. Okay, I'm already sold. But Documento.txt mentions something about a potential Goldilocks planet that's relatively close by.
It does. One estimate puts a potentially habitable planet at just 12 light years away.
12 light years.
A mere stone's throw in cosmic terms.
I mean, I complain about a 12-minute drive to the grocery store.
Imagine the interstellar traffic. Still, the fact that we've potentially found a neighbor that could harbor life, now that's exciting.
Okay.
From planets that are just right.
To the mother of all origin stories.
Let's dive into the Big Bang.
Okay.
Documento.txt reminds us that it's still the most widely accepted theory for how our universe began.
And it's not hard to see why.
Right.
I mean, the idea that everything, and I mean everything,
Yeah.
exploded into existence from a point smaller than an atom.
Mm-hmm.
That's enough to make your head spin faster than a neutron star.
It's a concept that captures the imagination, that's for sure.
Right.
But Documento.txt also emphasizes that the Big Bang Theory isn't just some wild speculation.
Right.
It's actually backed up by a ton of scientific evidence.
Like what?
Fill us in.
Well, for starters.
We see evidence of the universe expanding everywhere we look.
Okay.
Galaxies are moving away from each other, and the farther away they are, the faster they're moving.
All right.
This observation points to a universe that was once much smaller and denser.
Exactly as the Big Bang predicts.
So it's like the universe is still inflating from that initial pop.
Exactly.
And then there's the cosmic microwave background radiation we talked about earlier, which is like the faint afterglow of the Big Bang.
Right.
This radiation has a very specific temperature and distribution throughout space, further supporting the idea of a universe that began from a single hot, dense state.
So we have the expanding universe.
The cosmic afterglow.
But isn't there something about the types of elements we find in the universe, too?
You got it. The Big Bang Theory predicts that specific elements would have formed in the early universe,
Okay.
primarily hydrogen and helium, with trace amounts of lithium.
And guess what? When we look at the composition of stars and galaxies,
Yeah.
it lines up remarkably well with those predictions. It's like finding the universe's birth certificate with all the details neatly laid out.
Talk about a smoking gun. But
Yeah.
Documento.txt also explores some alternative theories to the Big Bang,
Right.
like the ecpyretic universe theory.
Okay.
This one suggests that maybe the Big Bang wasn't the beginning.
But just one beat in an endless cycle of cosmic expansion and contraction.
Okay.
It's like the universe is doing a cosmic dance, constantly expanding and collapsing, expanding and collapsing. It's definitely a mind-bending concept.
This theory proposes that our universe exists on a three-dimensional membrane
Hold on.
called a brane.
What?
Imagine a sheet of paper floating in a higher dimensional space.
Okay.
And every now and then, these branes collide.
And those collisions create a big bang-like event.
Oh, hold on.
Did you say our universe is basically floating on a giant sheet of cosmic paper?
Yeah.
Explain this brain thing a little more.
I think I missed a memo somewhere.
It's like this.
Imagine our three-dimensional universe as a flat surface.
Okay.
That's our brain.
Okay.
Now imagine another brain floating parallel to ours.
In a dimension we can't perceive directly.
Okay.
Every trillion years or so, these brains come close enough to influence each other.
Eventually colliding and creating a massive surge of energy.
Okay.
The Big Bang, if you will.
Okay, so no more cosmic paper. I got it.
But if this collision creates a new universe,
Right.
does that mean anything survives from the previous cycle?
Like, could there be remnants of ancient galaxies embedded in the fabric of our own universe?
That's the million-dollar question.
Right.
The ecpyretic universe theory is still very much under development,
Okay.
and there's no concrete evidence to say what happens during these collisions.
Yeah.
It's possible that some information, some fundamental properties, might be passed down from one cycle to the next,
Okay.
but that's just speculation at this point. So it's like hitting the cosmic reset button, but with maybe a few saved files from the previous game.
Right.
Now, while we're on the subject of alternatives to the Big Bang.
Documento.txt also touches on the steady-state theory. Right?
Oh, okay.
This one feels a bit like trying to fit a square peg into a round black hole.
I mean, how can the universe be expanding and stay the same?
It does seem counterintuitive, doesn't it?
Yeah.
But the steady-state theory attempts to reconcile the observed expansion of the universe with the idea that on a large scale, the universe always looks the same.
Regardless of where or when you're observing it?
So like it's static.
Think of it like this. Imagine a baking loaf of raisin bread.
Okay.
As the bread rises and expands, the distance between the raisins increases.
Right.
But the overall distribution of raisins remains relatively uniform.
So the raisins are like galaxies.
Constantly moving apart.
But new raisins are always popping up to fill the gaps.
Precisely. The steady-state theory proposes that matter is continuously being created throughout space.
Albeit at an incredibly slow rate.
Okay.
This continuous creation of matter, they argue,
keeps the universe's density constant.
Even as it expands.
It's like the universe has an infinite supply of cosmic dough. But if matter is constantly being created...
Wouldn't we be able to detect it?
You'd think so, right?
Yeah.
But the steady-state theory posits that matter creation happens on such a small scale.
That it would be incredibly difficult to observe directly.
So we just haven't found a way to observe it yet.
Right.
Okay, but not clever enough, it seems.
I mean, Documento.txt mentions that the steady-state theory kind of hit a wall with the discovery of things like quasars,
Right.
those super bright, super distant objects that really shouldn't exist in a universe that always look the same.
And then there's that pesky cosmic microwave background radiation again, that afterglow of the Big Bang that the steady-state theory struggles to explain.
Yeah, right.
The steady-state theory, while intriguing, hasn't been able to hold up against the mounting evidence supporting the Big Bang.
Right.
But that's the beauty of science. Theories are constantly being tested
Refined.
and sometimes completely overturned
Yeah.
as new observations and evidence emerge.
Speaking of theories that might completely overturn our understanding of reality.
How about we unplug from the steady state and jack into something a little more simulated? Documento.txt takes us down the rabbit hole.
Of the simulation theory.
Okay.
The idea that our reality might just be a super advanced computer program.
Right.
Like a cosmic video game designed by some unseen programmer.
It's an idea that's been around for a while, explored in everything from science fiction to philosophical debates.
Right.
But Documento.txt brings up an interesting point.
With advancements in our own technology,
Yeah.
particularly in areas like virtual reality and artificial intelligence,
Okay.
we're starting to glimpse the potential for creating incredibly realistic simulations.
Right.
So is it that much of a stretch to imagine a civilization
Right.
far more advanced than ours,
Yeah.
capable of creating a simulation indistinguishable from reality? It's like, if we're already playing SimCity, who's to say we're not just Sims in someone else's game?
Right.
Okay, I'm officially sufficiently freaked out.
But seriously.
If we are living in a simulation,
Right.
how could we even tell?
That's a good question.
Would we see glitches in the matrix?
Yeah.
Error messages popping up like, universe overloaded, please reboot.
Some physicists have proposed that we might be able to detect subtle inconsistencies in the laws of physics.
Okay.
Like finding a pixel that's slightly off color in a high-definition image.
Right.
These anomalies, they suggest,
Yeah.
could be evidence of the underlying code of the simulation.
Okay. I'll keep an eye out for any cosmic error messages.
You know?
Even if it turns out we are in a simulation,
Right.
it doesn't really change the fact that this is our reality, right? I mean, should I be less stressed about my presentation tomorrow if it's all just ones and zeros to some super intelligent being?
That's the philosophical heart of the simulation theory, isn't it?
Yeah.
Does
I'm
knowing
not even suspecting.
that our reality might be simulated
Yeah.
change how we live our lives,
Right.
how we value our experiences,
Right.
our relationships?
Yeah.
It's a question without any easy answers.
Well said.
Okay, from simulated realities to something equally mind-bending.
Documento.txt introduces us to the flip side of black holes.
Okay.
White holes.
White holes.
Black holes are those cosmic vacuum cleaners sucking everything in.
Right.
But white holes,
Yes.
they're like the mysterious cosmic outboxes that no one really understands.
Exactly. Well, black holes are defined by their incredible density and gravitational pull.
With nothing
even
able to escape once it crosses the event horizon.
Right.
White holes are thought to be regions of space-time where matter and energy can only escape, never enter.
So it's like a one-way door out of the universe?
Yeah,
That's,
a bit trippy.
But if nothing can get in,
Right.
how do we even know they exist?
Or where they lead to.
That's one of the biggest mysteries surrounding white holes.
Right.
They're still very much hypothetical, emerging from the mathematics of Einstein's general relativity,
Okay.
the same equations that predict the existence of black holes.
Okay.
Some physicists believe that white holes could be the other end of black holes,
Okay.
connected by tunnels through space-time called wormholes.
Wormholes. Okay, we're officially in science fiction territory now.
Yeah.
Hold on. Oh,
If matter gets sucked into a black hole and spat out of a white hole somewhere else in the universe, wouldn't that make for a pretty wild cosmic roller coaster ride?
it would be quite the journey.
Right.
But remember, we're talking about extreme conditions.
Unimaginable gravitational forces.
Right.
Not exactly a tourist destination.
Yeah, that's true.
And besides,
We don't even know if wormholes.
as they're often depicted in science fiction, are even possible.
Right.
They might be purely theoretical constructs.
I guess it's back to the drawing board for my intergalactic travel plans. Documento.txt doesn't let up on the weirdness.
Next up, we're diving into the concept of
Superfluid spacetime.
superfluid space-time.
I'm already lost and we haven't even started.
Think of it this way.
We typically imagine space and time as the backdrop
Right.
to the universe's grand play.
Right.
But what if space-time itself isn't empty,
Yeah.
but rather a type of fluid?
Yeah.
A superfluid, to be exact,
Okay.
with properties unlike anything we experience in our everyday lives.
Okay.
A superfluid.
So we're not talking about your average cup of coffee here.
Not quite. Superfluids are fascinating substances.
Okay.
They can flow without any viscosity,
Meaning they have zero friction.
so no resistance,
Imagine a liquid that could pass through any material without resistance.
like a cosmic ghost.
I can already see why this relates to space-time.
But what are the implications of the universe being a giant bowl of cosmic soup?
Well, for one thing...
Documento.txt points out that a superfluid universe could help explain some of the large-scale structures we see in the cosmos,
Okay.
like the formation of galaxies. Just as stirring a cup of coffee can create swirling eddies and patterns,
Okay.
a superfluid spacetime could create similar patterns on cosmic scales, leading to the clumping of matter that forms galaxies and galaxy clusters.
So the universe is basically one giant swirling cosmic latte.
Yeah.
I can get behind that.
But Documento.txt saves some of the weirdest stuff for last, right?
It's time to go subatomic with the theory of sterile neutrinos.
Okay.
Ah, yes.
Sterile neutrinos.
Sterile neutrinos.
These are like the introverted cousins of regular neutrinos.
Correct.
And regular neutrinos are already the ghosts of the particle world. They
Right.
barely interact with anything,
Making them incredibly difficult to detect.
so they're very shy.
Okay.
So we're talking ghostlier ghosts.
Right.
Why should we even care about these sterile neutrinos if they're so good at hiding?
Because despite their elusiveness,
Yeah.
sterile neutrinos could hold the key to understanding some of the biggest mysteries in cosmology, like the nature of dark matter.
Okay.
Documento.txt explains that dark matter makes up a significant chunk of the universe's mass.
But it doesn't interact with light,
Right.
which is why we can't see it directly. Sterile neutrinos,
Right.
with their extremely weak interactions.
They have emerged as a possible candidate for this elusive substance.
So these tiny, barely there particles could be shaping the entire universe.
It's possible.
It's enough to give you existential whiplash.
It's a humbling thought, isn't it?
Yeah.
All these theories.
From the existence of multiverses to the possibility that we're living in a simulation, remind us just how much we still don't know about the universe.
That's the beauty of it, though, isn't it? Every answer seems to lead to even more profound questions.
That's right.
It makes you wonder.
What other mind-blowing theories are out there just waiting to be discovered?
Exactly.
And if these 9 theories from Documento.txt have taught us anything,
it's that the universe is far stranger, far more wondrous, and far more terrifying
than we could ever imagine.
It's an amazing time to be interested in these kinds of things.
It really is. And on that note, thanks for joining us for this deep dive into Documento.txt. Until next time, keep looking up and keep those questions coming.